Good morning, everybody, and welcome to this morning's session on Step Beyond Spreadsheets. This is something that Rachel and I regularly do for those of you who have joined our sessions before. Step Beyond Spreadsheets is really focusing on SPSS Base. My name is Charles Quinn. I'm an analytics consultant with Smart Vision Europe, and I'm joined online today by my colleague Rachel Clinton. For those of you who maybe haven't joined any of these sessions before, just a few sort of housekeeping items to bear in mind, which is this session being recorded? Well, yes, it is. We record all of the sessions so you can listen to them afterwards.
Jola, can I interrupt? Could you just hide the? I can't see the slides at the moment because your Citrix piece is in the way. Perfect.
Does that better?
Perfect. Thank you.
Okay, that's fine. And with regard to getting a copy of the slides, we email out PDF copy to you after the session has ended. If you think it's useful and you want us to arrange a rerun for colleagues, then you can ask us, and obviously if we've got time we'll do that. We can do a private session for you. And with regard to asking questions, well, all the lines are muted, so we ask you to use the chat facility in the Citrix chat box. And obviously, if there's anything we can't answer, we'll run out of time. We'll follow up with you afterwards. It won't be a problem. If you don't know who Smart Vision are, we are a premium accredited partner to IBM. We specialize in the SPSS Advanced Analytics Suite. And we're made up of a team of people. We all have about 15 to 25 years really experience of working in statistics and predictive analytics. And the common denominator is at some point we've all worked as senior members of the heritage SPSS team within SPSS Incorporated. So the agenda today is really just to provide an overview of SPSS statistics and to talk about reading data from databases and spreadsheets, formatting the data, creating filters and banded fields, and then using a module within SPSS statistics, which is SPSS tables, to help us create publication quality reports. We're also going to focus on significance testing and finding statistically significant differences in groups. So that's one of the things we're going to kind of end the session on, looking at the different options we have to try and understand relationships within the data and measure whether or not those relationships are simply random or in fact are what we would regard as statistically significant. So first of all, an overview of IBM SPSS statistics. So it's been around a long time. So SPSS statistics has been around since 1968. It's definitely one of the world's most popular data analysis and statistical interrogation platforms. It's probably the best way to describe it. And it's used for a vast array of different applications, everything from epidemiology to survey research and business analytics and direct marketing and credit risk and predictive modeling and academic research and even asset management, where the data isn't really necessarily about people, but is about assets or about equipment. And within the base of SPSS statistics, and I'll explain what we mean by the base, but base, this refers to the core software. You know, you get a very, very large range of different statistical techniques one can use. So this include things like descriptive statistics such as crosstabs and frequencies and averages and measures of central tendency and what we call descriptive stats. But it also includes statistical tests like t-test and chi-square and ANOVA and correlation analysis. And it also includes prediction algorithms such as linear regression and even prediction for identifying groups such as factor analysis, which will cluster together similar columns of data, or cluster analysis, which will cluster together similar rows of data. So it turns out that SPSS statistics is built up from the base with a series of associated modules. These are bolt-on modules, a bolt-on functionality, which allow you to do very specialist things. And they simply appear as additional dialog boxes within SPSS. So for example, if you've got decision trees, you'll get access to the decision trees and it will appear simply under one of the menus within SPSS base if you've got that, and it's enabled simply by putting in a license code which will switch that on for you. So other sorts of modules would be things like the advanced statistics module, which involve a lot of multivariate statistical techniques, very commonly used within clinical research or experimental design. Things like the forecasting module will allow you to unlock the time series capabilities within SPSS. So that would be forecasting or looking at demand or supply forecasting, extrapolating out into the future, and so on and so on. In fact, if you want more information about any of these, you go onto our website and we've got actually little videos, little 2-minute demonstrations of a series of them, but also a description of what they all do. And the key here is, of course, there's a lot of additional functionality that one can have. So as an example of that, if we focus on one of them, here's one example here. This is the IBM SPSS tables module, and we'll be looking at that later on. But if you have the IBM SPSS tables module, and what you'll see is you'll see a menu item called tables or custom tables, and when you call that up, it shows you a dialog box. And this dialog box is a single dialog box, and it's for tabulation and reporting. And it allows you to build the table up visually. So you preview the table as you drag and drop the fields into the rows and columns, and you can move them around. And it kind of draw out a picture of the table that you're trying to produce. Once you've produced that, you can apply a range of different table looks. Table looks are something which are shipped with SPSS. You can create your own table looks, your own formatting, and we even have some table looks on our own website, Smart Vision Europe, and you can Google that and find those table looks and download them and use them for free yourself if you don't like the standard ones that come with SPSS. Okay, so we're kind of going to build this demo around 3 separate skill areas. When we think about people who are really good at analytical technology and people who can just demonstrate a considerable degree of prowess within that, generally speaking, they're able to demonstrate skills in 3 areas. They're able to show, they're able to read and format data correctly for analysis. So that'll be the first stage of how can I get data into SPSS statistics, whether it's in a database or in a spreadsheet. How can we transform and manipulate the data? Can we create new fields? Can we filter rows of data? Can we work with date and time fields? Can we band categories, band values together to create grouped variables? And then, of course, the analysis and deployment of the results is going to involve the actual statistical and descriptive analysis. And the deployment, of course, is going to refer to how we actually deploy those results back out, whether it be in the form of, I don't know, something like a simple report, or whether it be in the form of a series of values that we've created, such as predictions or forecasts that we want to push back out into a system. Now, these capabilities are exactly the same capabilities that one would use if one was really good at working with spreadsheets like Excel. And we're going to kind of use that as an example. We're going to compare and contrast spreadsheet analysis to the sorts of analysis that we do in SPSS statistics. So let's look at a little demonstration of that. If I just skip out, let's look at a spreadsheet here. So here's a spreadsheet we've got, and here's some data that we want to read into SPSS statistics. Now, this is actually a data set which refers to individual employees within the bank. So every row represents a different employee within a bank. And really, this type of data is kind of difficult or awkward to analyze within SPSS, within Excel and within spreadsheets, typically speaking. And that's because spreadsheets aren't really designed to analyze data where every row represents a different person. It's really, generally speaking, they're for summary data and very often financial information. But spreadsheets are very, very flexible. What SPSS statistics does really is it allows you to set the data up and then fire a series of analyses. In spreadsheets, there's it's kind of difficult to understand what the difference is between the data and the results of your analysis, because the data and the results of your analysis are very much the same thing. If I go and create a table from this, I'm effectively creating some data across the side here and then manipulating that data and creating some sort of summary measure such as an average or percentages. In SPSS, what you do is you read in the data, you analyze the data, and it basically produces results onto a completely different screen for you, a completely different piece of output for you. And the two things are kind of independent of one another at that point. So it's a very, very different concept. If I want to read this file, which is called employeeworkbook.xlsx, because it's a workbook, into SPSS, and it's pretty easy to do that. If I just close it down and say don't save, if I come back and skip out to SPSS, I think one of the problems that people have with SPSS statistics is when they see a screen like this is what you get when you load up SPSS, is that they tend to think of spreadsheets and they tend to think about manipulating the data within this data sheet. But in fact, that doesn't make things easier at all. That's not how SPSS works at all. This is actually just a way for us to edit the data and visualize the data. So if I want to read in that data set, I can just go to File, Open Data. And I tell it what file type I want to read. So here I've got a range of different file types. You can see that Lotus worksheets here. We've got third-party files such as SAS or Stata. We've got text data that we can add in. If I click on XLS data, I can read that in. If I want to read data from a database, I could go to File, Open Database, New Query, and then point it to, in this case, a SQL Server, or it might be an Access database, as you can see here. And I could read data in from that, so I could click on these tables. It would go and read them in for me, and I'd just say, okay, these are the ones I'm interested in, or I could go back and I could join tables together. Here we've got something called B2B IT products or B2B product categories, or something like that, and I could connect these together and read them in, and so on and so on. But really, it's just a case of pointing to the database itself, and then picking out the table that you're interested in. So I could say, okay, I'm interested in this basket analysis type table here, run, hit finish, and read that in. So you can see that reading in, non-native data is fairly straightforward. It reads it in. It's exactly the same approach that we would take when we're reading in spreadsheet data. So if I went up here and said, okay, I want to read in spreadsheet data, I can click on that data set here, employee workbook, click OK, and read that data set in. And it reads it in, and you can see that what's actually happened here is it's just read in very raw data. It looks very similar to what we saw in the spreadsheets. We got some decimal places, but the formatting that's within the spreadsheet has been more or less honored. We've got some unusual things here where, for example, this field here, which is actually gender, is very narrowly displayed. If I just drag that across, I can display it a little bit better, and you can see all the different column names here. So the first part, as I said, of people who are good at SPSS statistics are people who are good at reading and formatting data. Here I'm reading the data, but what about formatting data? Well, formatting the data means getting the data into shape so that we can actually, do something decent with the data. So let's have a little look at the at what's called the variable view. If I click on the tab here, we'll show you the variable view, and just have a little moment there to have a look at that variable view. So the variable view shows me each of the fields, and it shows me how SPSS statistics has formatted the data. So you can see here it's saying that this is a string field. It's not a number field. This is a date field. We've got width and decimals here, and we've got other columns here marked values and missing and columns. And this is very, very specific to SPSS statistics. This is what we do in SPSS statistics to kind of set the data up. So in SPSS statistics, you kind of front load the data. So for example, if I go back to gender here, I can see gender is just made up of codes, F and M. And really, I don't want them to be codes, and I don't want to just use a column header like gender. I want to have a nice label. So it says, sex of employee, because that's what it really reflects. So that when I do an analysis, I don't see the word gender appearing above it. I see a label like sex of employee appear above it. And instead of saying M and F appearing, I usually attach some little labels to each of these codes. So if I attach labels to each of these codes, excuse me.
Hi, you've reached Julia Johns. Please leave a message and we'll get back to you when we can.
So you can attach labels to each of these codes. If I type M here, I can type in male, and F for female, and then I'm attaching codes to that. And then when I come back to the data set, I can see that male and female appears instead of F and M. So male and female appear instead of F and M. And that means that these little labels here that are popping up are going to be used in an analysis. So if I want to use this in analysis, I can say, okay, well, let's just do a quick analysis of that. And I'll say, okay, let's do the frequency table here. I see sex of employees appearing. I click OK. And female and male appear now as values in a table. And we've got sex of employee. Now, if we compare and contrast that to this variable over here, which is job cat, which just has codes in it, I do a frequency table of job cat. You can see that because it doesn't have these values, it just has job cat and 1, 2, and 3. It has no labels attached to it. Now, in fact, this refers to the job category that people are in. So the job category that people are in really needs some formatting associated with that. So if I come back here, I could give this a nice format and so on and so on. So this is kind of what we do when we're starting out. You know, when we're actually reading in some raw data, we kind of format it the first time. Now, if you're reading the same data set every single time, and it's coming in as Excel data, or it's coming in as a spreadsheet, or it's coming in as a text file, or as from a database, you don't want to be doing this every single time. What you want to do is do it once and then use the formatting over again. And I'll show you in a second how to do that. There's another aspect, though, that's kind of key to working with SPSS, and that is what happens when we have missing data. So, for example, here, let's say that somebody's gender has not been recorded. Let's say that this person up here hasn't been recorded. If I click on the value up here, I can change this value here to X and say, actually, this person is code X, which means we don't know that person's gender that hasn't been recorded, and we don't have a label for it, so it doesn't appear in here. So is this something I can do about that? I mean, if I run an analysis on the variable sex of employee now, that's gonna appear as an additional value within there. So what we'd normally do is we go back to variable view and we'd say, okay, I'm going to pick up the field sex of employee, and I'm going to attach what's called a missing value to that, which is X for missing. If I click X at that point and then rerun the analysis, then it takes account of the fact that missing is actually the category X, and it doesn't include it in what's called the valid percent, which we can see at the bottom here. It's the valid percent. So that's good, because we don't have to then we can only use percentages which are based upon known values. Okay. So what else can I do? Well, one of the things I could do is, if I go back to variable view here, is I could give this a label as well. I could say, you know, X is actually unknown. So I could say this is actually an unknown value. And, you know, there are different reasons why data is missing. Sometimes it's refused, don't know, not applicable. So we can have more than one missing value that we can use again and again. If we click OK at that point, we can have missing equals unknown, one category that appears here. So it takes account of that, and that's kind of useful. But I did say earlier on that if I've done this already, if I've done this once already, then I can use this formatting again and again, so I don't have to set up each of the fields. So let me start from scratch. Let me just open up some data again. I'm just going to open up the Excel file again, and if I read that Excel file in, I can read it in again. It turns out that I've already got a data set where I've set this up once already. You can see that the output is still shown from the previous analysis, so it's kind of independent. I can shut down that output because I don't need it anymore. And what I can do is I can attach the formatting from an external file to this file, matching by the field name. As long as the field names are the same name, I can use that formatting again. So I can go to what's called the data menu up here and copy data properties from an external file. So if I click on browse here, I've got a little file here called employee just the variables, and it's just got the fields across the top. That's what variables means, just the fields. So when I click next at this point, it matches them by the ID, and it's going to attach lots of different properties to that. So these are the things that I've set up once already. If I click next again, I can hit finish, and it basically attaches all of this what we call dictionary information. This is called applying dictionary to the data, because I've already done it once. And if I've done it once already, it's already attaching value labels and variable labels and lots of missing values, which you can see here for 0 and code 9 for minority classification and so on. So that's our first section here where we've actually formatted the data and we've read the data in. That's the first sort of skill area. What about analyzing the data? Well, as you've seen earlier on, once it's kind of set up, we can go and fire analyses at it. We've got all these different sorts of analyses that we can fire at it, but we can also manipulate the data. So for example, if I wanted to do a frequency table, of course I can go here to frequencies and I can drag across variables and run an analysis on that, and it produces a frequency table for me. But alternatively, I can actually just right-click on these columns here and say, give me some descriptive statistics on that, and it does the same thing. It goes and punches out some descriptive statistics. If it's a continuous field like people's beginning salary here or the current salary, I can right-click and hit descriptive statistics, and it will do that. Or alternatively, I can go to analyze here, descriptive statistics, descriptives, and say, okay, well, let's look at beginning salary, current salary, and education level. And then I can go into options here and tell it what descriptive statistics I wanted to show. So I can say I'm not interested in the minimum and maximum, I just want the range and the standard deviation. And if I click continue at that point, click OK, it goes and squirts out and tells me what the average salary is, etc., etc. So there are some, there are some really basic sort of descriptives that we can do here. This gives us a count. In the same sense, if I wanted to go back to this output window and say, I want a chart from this, I can interact with this and say, okay, well, I'll just select some of these cells and say, go and create a graph for me, and it'll create a chart for me. Or alternatively, I can go up into Graphs menu here, Chart Builder, and say, okay, well, I want a pie chart, and I'll have a pie chart of employment category. And I can put that in there, and I can even say, okay, well, I want it broken down by something else. I'll have employment category broken down by their gender. I click OK at that point, and it will give me two little charts for females and males, showing me what employment category they belong to. So we can see that there are no female custodial workers within this particular bank. Okay, so that's fine, but what if I wanted to do something like a frequency table of salary? I don't want to just take the average, I want to take a frequency table of salary. Well, that's kind of problematic because there's an awful lot of individual categories of salary. So if I go back here to frequencies, see that it remembers the last procedure that we ran. This is because it tends to be a fairly iterative process of building this. So if I hit reset here and I pick across current salary, I could switch off display frequency table and ask it just to give me quartiles or cut points. So let's just see what happens if I don't do that. If I click OK, it just gives me this nonsensical table out because it's trying to take every single individual value of salary and tell me what percentage of people fell into that group. So it doesn't really make a lot of sense. If I don't like it, I can delete it. If I go back up here to frequencies, I can say, okay, switch that off. I go into statistics, and I say, give me the standard deviation, the minimum and the maximum. So very similar to what we had earlier on. I can go into charts and say, give me a histogram, which is a way of showing me the overall distribution. So it's very similar to descriptives, except I've got a little bit more control. I can ask for a few more statistics. But let's say I really do want to do a frequency table on this. A smart thing to do then is to band or to group the data together. So if I want to group the data together, I can go to transform and go to visual binning up here. And if I go to visual binning is a really nice way for me to group the data together. So I can go to visual binning here and click on that and click continue. And that will allow me to show me a distribution, just like the histogram we saw earlier on, of salary. And I can create the distribution here, and I'll create a new field called sal band. I can go to make cut points. I can ask it to make 3 cut points, hit apply, and it's going to slice it into 4 equal groups, so that we're going to get 25% roughly in each group. And because it's going to create codes 1, 2, and 3, we can ask it to make labels for that, and we can edit the labels. We can move these sliders up and down, and the labels will take account of it, and we can update it if we don't like where it's doing it. We can edit these values here, and so on and so on. So there's a lot of different stuff we can do here. So I can say, for example, here, I want this one to be, if I scroll this down, I'll back say, okay, I'll make this up to 37,000 exactly. So that'll be, up to, I can change this value here to 37,000. It's not $37,050, so it's a little bit neater. And it just gives me a warning. And so this one here is now going to be 37,000 and over, or over 37,000. So I'll say I can label it over 30, I'll make it dollar over 37K, let's say, something like that. If I click OK at that point, it says it's going to create a new field. It creates a new field for me. Here's my new field that's been created. And now, of course, I can right-click on that and say, give me some frequency table on that, and it goes and creates a frequency table for me. So now I have got the best of both worlds. I've got the data in continuous format and in what's called categorical format, so it's in categories. And this really opens up lots of different sort of statistical analyses that one can do. So, for example, let's say I wanted to look at salary band broken down by job category. Well, one of the things I could do is I could go to descriptive statistics and I could look at a crosstab. I could say, okay, here's salary band. I'm going to put that into the rows. And I'm going to put job category across the top here. I can go into what's called the cells and ask for row percentages and click continue and click OK, and that produces a little table for me. We've got clerical and custodial and managers here. So you can see that there's, practically no managers are beyond a certain, beneath a certain point. In the same sense, if I said, okay, well, I want to look at, a crosstab of current salary broken down by gender. So I could say, okay, let's look at that. It would give me a little table of that. So we can use this new field just as if we'd always had it, and it can tell us what percentage of people who are female earn less than 24,000. So off the 24,000 and under group, 86% are female. 24,000, 28,000 group, which is a fairly narrow range, it's almost equal, 51 to 48. And of the 28,000, 37,000 group, it's now 70% male or thereabouts, and over 37,000, it's 86% male. Now, if it turned out you wanted to filter out the highest group within the salary band, let's say that was skewing your results, so you weren't interested in people who were managers, for example. Let's say you just wanted to take out the managers and compare the custodial workers and the clerical workers. Well, we've got to, if we look at the data here, we've got a field here called a job cat, and we've got a category here called 3 for manager. And if I want to filter those cases out, I can go to data here, select cases, and say if condition is satisfied. That allows me to define a filter and go if condition is satisfied, and then say if employment category equals a certain grouping. We can go to the variable information here and say, okay, well, I want to take out category 3, or I only want to select category 1 and 2. So I guess really what I want to do is say if they're not equal to. So that will be the not equal to sign. If they're not equal to what? Category 3, because these are the guys I want to filter out. So then I just say, okay, that's category 3, hit continue, click OK. And what you notice is that within the data, you get this little filter field appears and tells me what's been selected and what hasn't been selected. Anything which hasn't been selected has a stroke through it. And now if I went back and did, okay, a crosstab here of current salary by gender, you'd find it's a very different crosstab because, beforehand we had 474 records. Now we have only 390, and that is, of course, because the managers have been taken out of the analysis, and we can prove that by going to crosstabs and say, okay, let's take out gender, and we'll look at our job category again. So we look at employment category, click OK, and you can see that there are no managers across the top. It's only clerical and custodial workers that we're comparing. So this allows us to zero in and focus and get rid of cases and filter out cases that we don't want to use. And we can reuse this filter variable again and again if we want to very quickly switch that on or off. You notice that the little message filter on appears at the bottom here. So this is kind of useful because it tells me that I've got a filter switched on just in case I forget. And if I click on data here, I can go back to select cases, or alternatively, SPSS actually keeps a record of the last 12 commonly used, most frequently used dialog boxes. So you can go back to select cases, it'll just call it up. And I can say select all cases and click OK. And now we're selecting all cases. So we're back to selecting all cases. And if I rerun that crosstab again, you'll see that suddenly we've got managers appearing back within the data. So that's kind of useful to be able to switch that on or off at will. So there we are manipulating the data. So those two examples of transforming and manipulating the data and playing around with it. We've got other sorts of forms of manipulation one could do, which I'll just allude to quickly now. If we went to the transform menu here, we can go to date and time wizard. So for example, we could extract part of a date or time. I could extract from their date of birth the month that they were born in. I could calculate with dates or times, so I could say, okay, let's calculate with dates or times. Let's say I wanted to calculate the number of time units between two dates. So this is quite an old data set. So I could say, you know, what's their current date minus their date of birth, and tell me that in years, and it would tell me what age they were today, which would be fairly elderly, some of these people, because you know, this was back in the 1980s. When this data was recorded, and I hit finish. I can also give them a nice little label if I want. I won't bother at the moment and hit finish. It tells me what age they are today. And then I could take off 20 years or something like that to get it back into the original units. But if I hit delete, I can just get rid of that field. I don't need it. In the same sense here, if I don't want the filter fields, I can get rid of that and just delete it if I'm not going to be using it again. Now, one of the things which is very useful, very powerful, is, of course, that we can automate our analysis within SPSS. SPSS predates Windows. So if I wanted to rerun a frequency table again, let's say I hit reset here to switch this back to the default settings. If I want a frequency table of current salary and minority classification, if I hit a little button here marked paste, it opens up a new window for me, and it's showing me the command that it's running there. So it's showing me that, you know, it's frequencies for minority and sal band, or the variable sal band, salary band, and I hit run, and it just goes and creates that for me. So in the same sense, if I want to read data in, format it, you know, create new fields, run an analysis, as long as I hit paste, such as here, and I hit paste, it'll just add it on to the previous command, so I can keep on adding these procedures in, and go to chart builder, and I can hit paste again, and it starts to add in more and more syntax, and then I can just highlight it all and run it all, and it just reruns that process again and again. So it's very easy for me to create batch jobs, if you like, where I'm going to grab the data on a monthly basis or a weekly basis or even a daily basis and have it run that. And I can have it run on a time basis, or I can create a little button at the top here and just click that button, and it will run that particular syntax job for me. Or I can do things like create my own custom dialog boxes. So there's a lot of functionality there that we can play around with regard to the automation of this procedure. Now, if I wanted to really play around and really format the data, you can see that when I'm doing things like crosstabs here, you can see that crosstabs is really just made up of rows and columns. If I threw in gender into the rows here, it wouldn't create a crosstab with current salary and gender in it broken down by employment category. Instead, what it would do is it would create two separate permutations, two separate crosstabs, one of current salary, first of all, by employment category, and then one of gender by employment category. If I want to combine them both together and have a lot of control over the data, then I need to use other sorts of procedures. So, for example, let's say I wanted to look at averages and compare averages. Well, one way in which I can compare averages is I could go to compare means and say, okay, let's look at the average current salary and beginning salary broken down by employment category and minority classification. If I click OK at that point, it gives me this little table of means. And I can double click on that, and I can go into pivot it just like you would in Excel, and I can put the statistics into what's called the layer box here, and it shows, so I can drill down into the mean, the number of cases, and the standard deviation, and just pull up these values. But what I can't do is I can't combine percentages and averages and really mix up these different tables and weld them together using the standard functionality. So to do that, what one would do is one would go to Analyze, Custom Tables, and use a Tables module. So this is an add-on module, and it's very powerful because it stops people from having to take this output and then paste it into something like Excel or another third-party tool to try and manipulate the output and get it into a format that they prefer, so they can create a nice table. So if I use the custom tables procedure here, I can combine all of these different sorts of variables together to create one big table using lots of different measures. So for example here, if I put current salary in the rows, I can put employment category across the top, I can add in gender either as a subcategory of current salary, or I can put it on to the end here and have it counted in the end here. Here I'm getting the row percentages thrown in. I can also add in years of education and have that thrown on at the end here as a median value, for example. Or I can go to the summary statistics and say, actually, I'll have the mean in there as well and apply to that, and so on and so on. I could say, well, what's their beginning salary as an average, or I could break down, their employment category by whether or not they are a minority classification or not. So I can really go to town on it and add in these different categories and play around with it, and I can go into totals here and say, okay, I want a total here and hit apply to that. I can change the name of the value from total, because sometimes people prefer the name base, and hit apply to that, and it puts the base at the top rather than total at the end, and so on and so on. So I can really play around with these different categories here, and I can say, okay, let's give this one a total as well and put that across the end and call that base, and click OK, and it produces one big table for me. So this is what the tables module is for. It allows me complete control over my tabulation, all my tabulation needs, and I could copy and paste that back out into Excel or export it as I wish. So tables is very powerful because it allows me to create a lot of different sorts of reports without having to resort to a third party, and I can give it titles, subtitles, and put in the date and time. So it's very much, it's kind of a reporting tool in and of itself, and that's one of the reasons why it's the most popular add-on module within SPSS. And of course, as I said earlier on, there's lots of different table looks. I can right click on this. If I don't like the formatting of this, I can go and say, okay, well, I want to create a new table look. I want to create my own custom table. So if I right click on it and say, double click on it, right click on it, and I can say, okay, let's look at the table looks we've got available here. And I can choose different table looks and say, okay, I'll have that one, or I'll have this one. And I got different versions. So if I click on this one, warning, you can see it changes the format. If I don't like that, I can right click on it, and one could go into the table properties here, go to the cells, and click on the background and say, well, actually, I'll have this as a sort of pale blue, if you like, and hit apply there. And maybe set up my corporate colors, or change the font in here to a different color if I wanted, and have it, as a bold white color, or so on and so on. So I could go in here and say, have that bold, and click OK, and that would create that. And then I could save that as default and say I want to use it as a default, or I could apply that table as a little file on a case-by-case basis. So there's a lot of control over the aesthetic properties of the table. Okay, I did promise that we'd look at looking at relationships between variables. I mean, here we are finding some interesting relationships between people's job category, let's say, and their gender, or between their salary and their gender, or their minority status and their gender. And in fact, this data was collected originally for a court case to prove that there was discrimination within the bank with regard to salary. And it was used, statistical analysis was used to prove it. So if we want to recreate some of that, I can put in, let's say, current salary into the rows here, and let's put minority classification across the top. And if I click on statistics, I can ask for, well, let's click on sales first of all. I can look at row percentages. Actually, let's ask for column percentages, because I want to take the percentage of minority classification. I can also ask it to display a little clustered bar chart. And here it is. It produces this table for me, and we can see that of those who are non-minority classification, 24% are under $24,000 versus those who are minority classifications, where it's 28%. On the $24,000 to $28,000 category, it's 21% on non-minority compared to 37% are minorities. And then it's more or less even between the 28 to 37% group, but where it really falls off, of course, is over the $37,000 mark, where 30% of non-minorities fall into this category, whereas only 7% of minorities fall within that category. Now, it could be that these fluctuations are simply random, and it could be that one would expect to see them all the time anyway, but we want to really prove that, or detect the degree to which these are random or non-random. If I recall this dialog box and call it the crosstabs again, and go to statistics and switch on chi-square and click OK, and that gives me a chi-square value. And the chi-square value tells me the probability that what we're looking at here is simply random. So that means that the smaller the value, the less likely it is that one's looking at a random situation or a random result. and one would regard this relationship between minority classification and current salary as statistically significant. And in fact, here's the chi-square test. It gives you more than one chi-square test, but to make it easy, if I double-click it and right-click on the top here and say, what's this? It tells me that this is a significance level. It's based on an asymptotic distribution of a test statistic. Asymptotic means estimated, means it's an estimated value. But it tells me that typically a value of less than 0.05 is considered significant. So we can see that these values are very much less than 0.05. They're not actually zero. It's just that it's run out of decimal places. They're saying that the probability here that current salary and minority classification are in no way related to one another is very, very small. That your minority classification makes no difference to your current salary is very, very small. And we would, in fact, reject the null hypothesis that these two variables were independent of one another. And we get a similar result here, as you might imagine, when we look at gender, and so on and so on. What happens when we're comparing averages? Well, when you're comparing averages, you want to look at mean salary versus minority classification, then that would typically be a t-test, and one would interpret it in a very similar way to this. I'm not going to do a t-test, but instead I'm going to show you a trick, a way in which we can show how averages can be compared to one another, and that is by comparing what's called the 95% confidence intervals. And there's a way in which we can graph this, and it's one of the ways that I tend to choose to graph averages. If I go to the graph builder here, the chart builder here, if I hit reset, I'm going to do what's called a error bar. I'm going to ask for what's called an error bar, and if I go to the chart builder here and go to the bar chart up here, I can ask for what's called a clustered error bar, and I can put that in. And I'm going to look at the relationship between education level, and I'm going to break that down by their current salary and by their minority classification. So I click on minority classification here and click OK. What we see is we get this strange looking chart that comes out. And in fact, it's not so difficult to interpret it. But what's happening here is it's saying that for those who are in a minority classification, interestingly enough, for those who are in a minority classification, the average value shown here is a circle, and the upper and bottom part of the error bars, the whiskers of the error bar, if you like, are showing the 95% confidence interval. So it's saying that this is a sample that you've based this data on. If we were to repeat the sample 100 times, 95% of the time, the mean would be between these 2 points. So it gives us an idea of the reliability of the mean. And it's based on two values. It's based on the number of cases that you have within this category and the standard deviation, the amount of spread within that category. So it's kind of giving me an idea of the reliability of that average. What's interesting here is that for the people who are in a minority classification, they tend to have slightly more years of education on average than those who are not in a minority classification for the under 24,000 group. Once we get to the 24,000, 28,000 group, they're kind of about the same. And by the time we get to the 37,000 group, well, it seems to be the same. It seems to be the people who are in a minority group tend to have slightly fewer years of education. But on the over 37,000 group, they're not so different from one another in terms of the average years of education, which is interesting because they're probably very different in terms of the average salary. But when we look at minorities, of course, but we can see that the 95% confidence intervals for this group are much further apart. That's because there are much fewer cases in here, so we can't be as confident of the values. So error bars are a nice way to show how these groups kind of vary. If we did the same thing again here and I said, okay, let's throw out minority classification and put in gender instead, we see a sort of pattern here where years of education now in this case tends to ascend each time with each category. The males tend to have more years of education on average than females in this salary group, but not in this salary group, but in this salary group. So it's a very uneven relationship here. It's a nice way of showing averages rather than simply showing them in terms of just showing the single value, the single mean. We can show the 95% confidence intervals, and that's quite a nice way to do that. So here we've created a whole series of output. And we've gone through this process here of saying, well, okay, we've brought some data in, we formatted that data, we formatted the data partly manually, but we've also used the data, copy data properties and used an earlier file formatted. We've manipulated the data by using things like the visual binning and select cases to filter out cases. We've analyzed the data using a combination of frequency tables, descriptive statistics, crosstabs, comparison of means, and very importantly, of course, the custom tables module, which allows us to produce very nice reports rather than the sort of system reports. We've also seen some graphs here. What about actually exporting these results? Well, you'll see that when I look at the results here, if I go to File, Export, I can actually export the data in a very wide range of different formats here, such as PowerPoint files, PDF, HTML, even back out into Excel or into just graphics itself. So if I said, okay, as an example here, let's just use Word. I'll say I'll create Word. I'll create a little report called SBS, A Step Beyond Spreadsheets report.doc. I only wanted to show the visible stuff, not the stuff that's hidden within the report, which is kind of hidden here. This closed book symbol that tends to be logging. If I click OK at that point, it just exports that out as a web report. I would normally go in here and clean this up and just get rid of titles so that the page breaks were correct. But you can see here it's honoring it. It's a actual table that I can manipulate within Word. And this could be a PDF, this could be a PowerPoint file, and we can export it very, very simply. So this is an example of deploying the results back out as a report, and as you can see, it's very easy to do that. Okay, so that's a quick tour through Step Beyond Spreadsheets, a demonstration of SPSS statistics and how that differs from using Excel or spreadsheets. I'm pretty sure that you get a pretty good sense of why SPSS might be more appropriate for this type of data. You know, conversely, we wouldn't be using SPSS to analyze our accounts normally because it's not an accounting software, but it is very, very good where every row is independent of one another, and it's very, very good where we want to really fire a number of analyses at, let's say, survey data, or where we want to do analytical reporting on marketing, for example, or in this case on HR data, looking at employees. Okay, so it turns out we've got a little starter pack, little offer that we're running here for people who haven't got SPSS, and it turns out, you know, if you don't already have SPSS already, then we've got an offer that's running, which is basically a 15% discount on the IBM list price because we're able to do that. So if you make a note of the offer code, then we'll honor that. You can also add 2 days of personalized on-site guided consulting and training. So we'll come on-site and train you on how to actually use this. The codes are up there for you to do that. We also add in 1 year of technical support for the first year. So I'll give you a moment to just make a note of the offer code. But of course we will be sending out the PDF to you afterwards, so you can see the slides. Okay, you can also go onto our website. There's lots and lots of different examples. We've got lots of videos of the various products that we sell, and examples and downloadable content that you can make use of. So it's useful to go on there, and you can see that under the resources menu. And if you want to understand the differences between the different modules that I showed right at the start, then this is a very good starting place for that. Makes it fairly easy to understand. As regards working with Smart Vision, well, we're a premier partner, so that means we can sell the software directly to you. And we're a smaller company, so we're generally more agile and responsive and generally easier to deal with. But as experts in SPSS, that means we also offer classroom trainings, courses, side-by-side training support, so we can work with you side by side. We'll do skills transfer consulting, or we'll do consulting based upon your actual data. We'll help you work on a particular project. We'll run booster and refresher sessions so you can get the most out of your SPSS licenses, and we'll generally give no strings attached advice. We are a support providing partner, so that means you can source your technical support directly from us, and we offer telephone support that includes how-to support as well as just, you know, error messages and help you interpret that. We will actually go a little bit beyond simply error messages and try to help you figure out how to do something. Okay, we do hope you find that useful. We do run these on a regular basis, of course. So, you know, if you think it's useful and you want to see some of the other sessions that we've run, you can either go onto our website and register and see some of the recordings from the other sessions. You can see some of the video recordings we've done there, or alternatively, we've got a whole raft of sessions coming up in the new year, and you'll see that schedule on our website. So simply go and register, and we'll remind you at the time as it comes closer. And you can log in and see another session, perhaps on another topic or another piece of software. In the meantime, we hope you found that useful. Any questions that you have, please drop us a line and we'll follow up with you afterwards. Thank you very much and enjoy the rest of your day.